Really very pleased to introduce this evening's speaker. Dave Dawson is an applied ecologist and a long-standing member of both the LNHS and the ECSS, and obviously, as you've just heard, that he's planned some really excellent lecture series for them. He's developed several census methods for use in citizen science and also for studying long-term trends in both animal and plant populations. We're really delighted to have him here to talk to us this evening. I'm going to stop sharing my screen now and I'm going to hand you over to Dave. So yeah, when you're ready to start sharing screen, it should be okay. Yeah.
Okay, I hope you can all see that, and thank you very much for that introduction. There's really two stories tonight, and I've got rather a lot to say, so excuse me if I gallop a bit. I've been counting birds for the best part of 60 years. I'm addicted to it. And I'm going tonight to be introducing you to two particular studies. But to begin with, you see here that I began an academic interest in bird counting way back in 1973 and in New Zealand, which is my native country. And I developed a bird counting method which is still in use there today. And in the 80s, I reviewed methods and their application. Here's a few published accounts from that. So I began quite early on in thinking about bird counting. Now I want to leap straight in to the first of two studies which I want to illustrate garden bird counting with. And this is a study, as you see here, done in suburban gardens in the London Borough of Sutton back in 1989. Now, the London Borough of Sutton there, you see there towards the bottom, was interested in the birds of suburban back gardens because they wanted to develop planning policies resisting the intensification that was going on then by buying up back gardens and building new homes at much higher density on those back gardens. So they commissioned the then London Ecology unit to do some work on this subject. It was obvious to us that there would be a major effect of suburban housing density on birds, but it wasn't obvious from the published literature. There was practically nothing that actually touched on the subject. So it was a bit of interest to try and find out more about it. The typical garden in Sutton and elsewhere in London was of moderate size. Here you see a semi-detached house with houses there with smallish gardens, very largely lawn, and a few trees. At the affluent end of the spectrum, you have big space between the parallel roads and large gardens, and with trees as well as shrubs, and more variety and structure. So the leafy gardens of detached houses. And at the other end of the extreme, you have the terraced houses where you're lucky to have much of a garden at all. It's pretty small, a sort of pocket handkerchief, little greenery. Now, it's pretty obvious that in such tiny spaces to do a study, only a point counting method is possible. If you're trying to do a transit, you'd find yourself pacing around like a caged lion. You wouldn't travel any great distance. So you're essentially standing still. Now, point counts lead themselves to designing studies of this kind. The 5-minute point count method, which is the one that we use, is an index method, and each species is measured on a different scale of abundance. And we had points, as you see there, spaced out, and study areas which could be fairly homogeneous. So the numbers in those study areas are the number of points in each. And the study areas are fairly homogeneous in terms of their suburban housing density. So the subject that was under consideration, the density of houses, was kept as constant as possible. The reddish areas being the lowest density housing, and the blue intermediate, and then the dark brown being the highest density houses. And you see the date range there. One observer was used, and there was a systematic visiting schedule, so that all of the extraneous factors were more or less equally spread among all those counting points. And so you could afford to ignore their effect pretty largely. And we were able to follow strict experimental design here, the sort of thing that was invented by the great biological statistician R.A. Fisher roughly 100 years ago now, and principles which still apply today. So the precision of the point count allows you to do a thoroughgoing study. It's designed, as you see here. You can do what's called blocking. So if you look here, that's a block. It's in one general part of London, but with a contrast. And here's another block in another general area of London, but closely spaced places which contrast in housing density. And also replication. If you look at the top left one, low density housing compared with medium density housing, we have replicates. We've got another one there, we've got another one here, we've got another one there. So you've got blocking, you've got replication, you've got several points in each of those blocks. And you can do what's called an analysis of variance on the end result. Now, to cut a long story short, because we haven't much time tonight, we were able to show a large number of interesting results as a result of this careful study design, using a method which is really the only method that you can use, standing in one place, counting birds from one point, and in this case over a duration of 5 minutes, using essentially the same method as we developed for New Zealand forests. And this is the upshot. So you see here that there are two species in green there on the left, which were significantly more abundant in terrace housing than elsewhere in the studies. And that was housesparrow and starling. They are really specialists of built development. Then there were 10 species where we either didn't have enough data, or the effect on housing density was rather modest, where we had no significant difference. And they're the ones in blue. And then 13 species which were significantly less abundant in the high density housing than they were in the low density housing. So finding the result that London Borough of Sutton were interested in, and we can look at it a different way. There's 5 species above that 100% line. They're the only ones which appear to have where high density housing appears to benefit those species. And then, however, there's 20 below the line. So there's a clear advantage of that low density housing in terms of bird populations. Study done, result found. Using a method which is really just about the only method you can use within gardens. Okay, now for the second study, and this is the one that I want to spend most time on tonight because I've spent a lot of time on it recently. Now, this is a different kettle of fish. This is really the sort of thing that anybody can do in their own private garden. This happens to be mine, and that's me. Okay, so why should a citizen scientist bother to count birds in a garden? Well, or count birds anywhere for that matter. Well, the first thing is the delight of discovery. After counting something like 8,500 bird counts in my back garden, I was delighted one day to see a raven being mobbed by a group of carrion crows. I didn't expect to see this, but you make all sorts of unusual discoveries if you spend enough time looking and recording. And probably the next raven to be seen will be a very long way ahead. And then there's a matter of knowledge and posterity. That's why a lot of people participate in organised schemes, or indeed organise their own results. Now, the great Australian ecologist used a very good example of how you can go wrong with just reciting anecdotes. Now, he was interested in populations of kangaroos in Australia, and he read all of the early explorers' accounts of kangaroos as they were exploring the hinterland of Australia. And they were commenting on how there were many kangaroos here and few there, and we saw a lot today. None of them said anything quantitative. It was all relative to their experience then, not before, not after, but a snapshot in time. But of course, nowadays, we don't know what was normal to the early explorers. The kangaroo populations may have gone up tremendously since then, or gone down tremendously. So a lot means nothing to us nowadays. So if you just record how many you might have seen in a day's march or something like that, just a tiny bit of quantitative information, that historical account would have been ever so much more valuable. So that's why we are contributing to knowledge and to posterity by just putting a little bit of discipline in, telling people a little bit more about what we did to find out whether there were a few or many. And there's those kangaroos in an artist's representation. Actually, the best information we have from back then. The written accounts are useless, really, for telling how kangaroos might have changed since those days. Right, so we're interested in documentation. And we might want to document quite trivial things like, and things which we don't anticipate. When I began my study back in the late 80s, I had no idea that I was going to document the arrival of the ring-necked parakeet, but I was documenting what was going on over time. And lo and behold, they turned up. Similarly, I had plenty of house martins back then, and I had no idea when I began that they would decline to extinction in my local area. So we're documenting things, not things that we expect, but things which are going to happen anyhow. The other thing that it's helpful for if you're doing a regular routine count in your back garden or something is that it gives you a chance to take a pause from ordinary everyday routine. It takes me about as long as it takes me to brew a pot of Turkish coffee to do my bird count in the garden. So I can put the coffee on at the beginning, come back inside, and there's my coffee ready. Short period of time. It's easily done. It's also good for you. There's a lot said these days about the health benefits of enjoying green open spaces. So that tiny period of time, routinely every day or every now and then, gives you a little plus. And it also gives you release from the stresses and strains of ordinary household management. You can leave the squabbles to deal with each other or for somebody else to deal with. You can just take a little pause and relax for a moment and shed those stresses. And also the method works. So you're not just doing something trivial. So what happens when you're detecting a bird? First of all, it's got to be out there. You're not going to detect a bird that isn't there, but there's more than that. It's got to be visible. You're not going to detect it if it's invisible, if it's out of sight somewhere. Or it can be audible. You've got to be able to hear it. So you've got to be able to see it or hear it. So, but at first it could be out of sight and quiet and turn up later. So that causes problems. You don't know whether one that's turning up later is necessarily the same one that you've recorded already. You could be looking the wrong way, so you miss it. And you could be taking notes and you could miss it. And you need to detect it, but not to misidentify it. You may see something brown and spotty and wonder, what on earth is that? So all sorts of things matter, your acuity, your concentration, and your experience. But don't be put off, you can easily acquire these. Now, counting a bird. The count in any 5 minutes is going to be a sample. The black ones here are ones that we've detected, and the white ones are ones which were there but we missed. And you can see that we're getting some and missing others. but all very randomly. Next time you go to that same point and spend the same amount of time the following day, or even 10 minutes later, you'll see a different set of birds. So you need lots of counts for a good average, and simple rules to avoid the unnecessary variation that would otherwise come about. Now, some of the methods that we use are called index methods. This is a bit of technicality. This is where you're assuming that the variation in what you count reflects the variation in the true number. So each species has its own detectability. So it's measured on a different scale from each other species. And we have here an example of the sort of thing that might be happening. We have a conspicuous species like the carrion crow, where most of the birds that are there we're picking up, and an inconspicuous species like the goldcrest, where we're picking up relatively few of what's there. But we're assuming a straight line relationship between the numbers we pick up and the actual numbers that are there in both cases. But they're on different scales, one for each species. That's an index method. Absolute methods collect locations attempting to get a true number. And I tried both. Right. So what did I do? It's one garden, so I had to use point counts. I couldn't pace up and down like a caged lion, as I said earlier. I stood in one place with only minor excursions to get a better view of something that was sounding off, or where I got a fleeting glimpse of something. I have done that number of bird counts over the 34 years of my study, and I'm looking for an optimum easy method. And I did a point count with 3 different durations, 2.5 minutes, 5 minutes, and 10 minutes, combined together. So I recorded the first 2.5 minutes separately, and then the next 2.5 to make 5, and then the next 5 to make 10. And I noted all detections, noting how each bird was first detected. I counted them as near or far, depending on whether they were within or beyond an estimated 25 meters distance. I did it throughout all seasons and times of day. I noted weather and noise, and here's my counting point. It's in my back garden. You can see the point in the middle there, the 25-meter radius around it, and you can see the tube line running not far away, a little over 25 meters away. You can see that my radius included some of the housing as well as the back gardens. It's a triangular block of back gardens, my one of medium length, shorter ones in one direction, longer ones in the other direction. Not typical suburbia, nothing is, but suburbia. And there's that counting point on a smaller scale aerial map. You can see Wimbledon Park off to the west, with the All England tennis just beyond that, even further west. You can see the tube line snaking through the middle of the picture. You can see pretty standard suburban housing to the north, and you can see pretty posh suburban housing to the south. You can see railway yards, you can see commercial development, you can see the River Wandle. So there's a lot of things in that view. And I was counting at that point right in the middle. Okay, and I tried to use what's called binomial distance sampling. This is one of those methods that's meant to be absolute, to give you an actual density. And it's a bit technical, and it makes lots of assumptions. You're assuming, first of all, a snapshot. So no birds are moving, not naturally or in reaction to us. So you've got to have a pretty short period of time. You assume that all the close birds are detected. You assume that detectability declines with distance, depending on the species. With an inconspicuous species, the ones on with the high peak there on the left, they're inconspicuous. So you're getting large numbers within your 25-meter radius, smaller numbers beyond. But for a conspicuous species, it's the converse, the green one at the bottom. You're getting large numbers beyond your 25-meter radius and smaller numbers within it. So you're getting a handle here on detectability through the number of birds you get within and without your 25-meter radius. You're assuming all sorts of other things, like the area sample being homogeneous, and you could see from the maps and aerial photographs I've shown you that it wasn't. And that the points are randomly placed. Well, we've just got 1 point. I suppose it's random, but it was my back garden, so perhaps it wasn't. And that the distances are accurate. That's a tremendously heavy assumption when you're hearing things and not seeing them. Estimating distances is problematic. But it's worth doing, because otherwise you have no handle on the differences in detectability between species. So coarse and simplistic and unrealistic though it is, it's worth doing. And I did it. And you can see here that depending on the percentage that you detect near, you get an effective plot size in hectares. And you can also see by looking at that, the method performs poorly when the percentage of far detections approaches 0 or 100. So we need a good number of detections to try and avoid these problems. And this meant, in fact, that I could find no time trend in the effective plot size for any of the species I was studying. I found effective plot sizes, but I couldn't show that they varied with time over those 30-odd years of my study. So moving on. Okay, each year on my trend graphs represents about 45 points, so it's quite accurate, but there's still a lot of variation from year to year. And long time series allow quite small trends to be detected. Here for the Dunnock, you see a small decline over those 30-odd years. And in contrast, you can also detect much bigger trends. Here's the house martin. You can see a tremendous downward trend to extinction. So you can pick these up because you've got a very long time period that you're looking at. And is there a lockdown effect? Looking at the Dunnock, you might think possibly yes, that last point there looks a bit higher than the trend line. House martin, no use, they were down to 0 by the time lockdown came along. So I was able to look at whether there was a lockdown effect. You can use standard statistical methodology for looking for outliers. And I did that. And it told me that for no species was last year's point an outlier. So for no individual species did I find anything different from what we would have expected from the immediately previous years. So sorry, folks, if you were after a lockdown effect, there wasn't one. I also tried a voting thing. Were they above the line or were they below the line? And on a voting basis, we still didn't manage it. Even with the 20-odd species for which I had quite good results, there were some in one direction, some in the other. I think lockdown effects on birds, at least in suburban gardens, are pretty imaginary. So we got some quite big trends from this study. You can see that you can get quite useful results. The goldfinch really took off. The blue tit really declined, and that was quite a surprise. Here we are, another arrival, one which not everybody would welcome. The wren was a surprise too. We've long known that the wren doesn't like bad winters, but we haven't had a series of worsening winters, quite the converse, but the wren numbers have declined. Song thrush, the national decline's well established, and we found it locally. Blackbird declined. So declines that we might have expected, declines which everybody knew about anyhow, but others which are a little more subtle. Here's some more. Robin, interesting trend. The greenfinch, everybody knows the greenfinch story, and there was a significant decline for the greenfinch. Black-headed gulls declined. But for a good number of species, even with 30-odd years of counting, I couldn't detect a trend. Wood pigeon, a very significant bird in great abundance and representing a large amount of biomass. It seems to be roughly in the same numbers and biomass now as it was 30-odd years ago. Great tit, same. Carrion crow, same. Believe it or not, the swift, very variable and very low numbers. So I may have yet to show a statistically significant decline there, but I've got to keep going for a few more years. Goldcrest, again, pretty small numbers, and I couldn't show that that apparent trend is actually real. Okay, so you can pick up trends, and that's interesting. But what else is going on? Here's another trend, and this is my subject species, so I'm quite interested. House sparrows in my garden declined tremendously to under 0.1% of the previous numbers. Now, what about that sparrowhawk? The sparrowhawk turned up, and it shows somewhat of a converse trend to the house sparrow. And that matches a theory which is about Bell's theory about the recovery of sparrowhawks and the decline of house sparrows. There's no doubt that there's a very good correlation between the two if you look at when sparrowhawks turned up in different parts of the country and what happened to house sparrow populations at the same time. But that's a correlation, and here's that correlation shown locally. Okay, now why bother counting garden birds when it's being done already? There's the Garden Bird Watch, and suburban areas are quite well documented in the Breeding Bird Survey. So what extra might we get? Well, there's things like that house sparrow story, the detail. Now, I've also got 6 extra years, and I find that most of my trends agree with these national monitoring schemes. And here I'm comparing my results with the Breeding Bird Survey. The extra 6 odd years are at the beginning of my survey. And you can see here for the blackbird that we're agreeing quite well. Same for the carrion crow. But the blue tit, something's going on here. Either the London trend in the Breeding Bird Survey is a bit awry, or there's something special going on in my garden, or with me. Same for the house sparrow. The house sparrow in the Breeding Bird Survey declined, but not half as significantly as it did with me. I account for this because the house sparrow is semi-colonial, and we've got here, my colony just disappeared. The light switched off. It blinked out, whereas other colonies not far away kept going over this whole period. And I think that the Breeding Bird Survey is picking up the average of those colonies, some which have blinked out, some which have not. I happen to be studying just one location, and there the light blinked out. And the great tit, oh dear, there is a discrepancy here. Oh, I'm wondering if it's me. Anyhow, we don't know. We've got these differences. The explanation is another matter. But they do suggest local effects, me or the location. Now, when should we count birds? What hour of day? Here I've looked at a large number of species and I've weighted them equally. So I've given each species an equal vote here, and if there was no effective hour of day, they'll all average out at 100. You can see clearly that they don't. In fact, you're doing quite well if you count at some time in the morning. Between 6 o'clock and 10 o'clock in the morning looks best. But anything before 8 o'clock at night will still give you some kind of a reasonable answer. There isn't much going for it, but choose a time and stick with it. So I actually use between 7 and 9 o'clock. The reason being that those were the only times that for the entire 30 odd years of my study, I had good samples in every year. So I discarded a lot of my results for all of the trends that you'll be hearing about this evening. I just looked at those counts made between those hours. Right, so that will work, or will it? It doesn't serve all species, but there is just one exception. I looked at all the species individually, and the swift's really the only outlier. Okay, same in relation to dawn. You're often told by people that advocate counting birds to head for that period just around dawn when everything is conspicuous. That's not true. They're not. if you average 20 common species the same way as I did on that last slide, where they would come out at 100 there if all those hours were the same. Here I'm looking at half-hour periods around sunrise. Sunrise, as you can see, it's the different coloured bar in the middle. The black ones are before sunrise, and the nice sunlit ones are after sunrise. And you can see it doesn't seem to matter when you count in relation to sunrise, at least within the first 3, 4, or perhaps even 5 hours after dawn. That's fairly satisfactory, really. And if you look at the individual species, most of them fit that pattern. So if you want to punish yourself in summer, count at dawn, but there's really no advantage. Okay, now over the whole period of my study, the species richness that I found, the number of species, the average number of species per count declined. Oh dear, what's going on? Is it me? Could be me. I was quite young, not very young, but quite young when I began the study. Quite young, I think, relative to me now. And partway through, I had 2 cataracts replaced. So my eyesight improved overnight, or more or less overnight. It took a couple of weeks. And then a bit later, I got hearing aids fitted. Here's my left ear and right ear results. I don't study them in detail, but it shows that I had hearing loss, and my hearing aids in theory should have helped with that. So here, that could account for that overall decline. But it may be also that the species themselves were declining on average rather than increasing on average. So here's a look at the hearing aids. I couldn't do much about the cataracts because I couldn't swap those cloudy lenses for the clear ones back in and out for alternate counts. I couldn't study the effect of cataracts beyond a possible change, a step change around the time that I got them fixed, and there wasn't one. So hearing aids, what about them? Well, for many species, there seemed to be little effect at all, as with the carrion crow here, both with and without hearing aids. And I did every alternate count with hearing aids in and hearing aids out, and a huge number of them. And you can see not much effect. So most species were like the carrion crow, no great distance. Some, surprisingly, I seem to get more without the hearing aids in place than with. Oh dear. Hearing aids can make sounds a bit tinny, but I didn't expect that. Others, however, showed higher counts with the hearing aids in, and in some cases, quite extremely so. So it looks that if you've got poor hearing and you've got hearing aids, use them. You can get other brands of hearing aids. That's just used as an example. Right, now my colleague that published the original 5-minute bird count with me, Peter Ball back in New Zealand, got really worried about his counts. He was worried when he heard another bird. Was it the one he'd heard before, or was it a new one? And he made very careful notes. He stressed and he worried, spent a lot of time looking at his notebook and making diagrams of where things were rather than counting birds. And clearly there's a problem. And nobody talks about this in the literature on bird counting. Here I'm looking at all species weighted equally, and I'm comparing 2 things here. I'm comparing 2 rules that you might apply when a new detection comes along. Is it that bird I heard before, which is skulked along unseen and is now calling from another bush? Or is it a new one? You literally don't know. The same, you see a bird fly over like a swift or a carrion crow. It disappears. And then shortly afterwards, another bird flies over, roughly from the same place that that bird disappeared. Is it that bird swinging around and coming back? Or is it a new one? You don't know. You have no idea. And you need a rule to account for these. What do you do? Now you can see that with the progress of time, you count more birds anyhow, with whatever rule you're applying. The first rule, the black one there, is if in doubt, you count it again. So you'd count a lot of swifts as they're swirling around, going out of sight and coming back in again. And the same with the carrion crows. and you would count a bird, a robin, which might well be the same robin, which has moved along that railway embankment at the bottom of the garden and is now singing from a different place. Is it the same robin or is it not? You'll be counting it again. And the open circles are the rule where you don't count. And you can see that regardless, you're picking up more birds with time. And what's happening? What's happening is there are two processes going on. Birds which were previously skulking are revealing themselves. So those are birds that have been there all the time, but they're telling you that they're there. That's good. But there's birds that have moved unobserved and putting you at risk of counting twice. That's not good. So because of that, I recommend the strict rule, the open circles. You only count a bird if you're confident that it's new. It may be a female blackbird instead of a male. It may be a bird which just couldn't have flown from that distant call in one direction to the distant call in the other direction in the 10 seconds between the two. But only with, and it could be where you saw a flock of 6 together. So you're taking the maximum number that you're getting, and you follow that rule. And because you just keep accumulating numbers, you've got to draw a line under it. And most people draw a line at 5 minutes. In the international literature, people who do bird counts tend to converge on round about 5 minutes duration. And that's what I did. So all the other graphs that I'm showing in this talk is based upon 5 minutes duration. So I'm just ignoring the second 5 minutes. And it's on that strict rule. So I'm ignoring the slack rule. So I'm discarding a lot of data. And I'm recommending going for that particular combination. Okay, now what about month of the year? A lot of people say, well, let's study the breeding season because birds are doing interesting things then and they're less mobile. They're not moving around so much. But in fact, if you look at this, you're getting roughly the same number of bird species, regardless of what time of year you're studying. And there's interesting things going on at other times of year, like wintering processes, migration, dispersal, you name it, seasonal foods. So why bother just confining your attention to the breeding season? It's not marked there, the peak isn't marked. And it depends upon what questions you're interested in. There's nothing to stop you counting in any months of the year, in any season. And here's a few examples. I'm going to skip through these quickly because I'm running very much short of time. But you can see here that you get a totally different seasonal occurrence depending on what species you're looking at. And if you're studying a portmanteau thing of all species, you really want to look at all months because different species have different optimal times anyhow. There's no best time. I could keep going. So why bother counting at all? Can't you just look at presence absence? People do. Some methods look at presence absence. And it's good, it's okay for the less frequent species. Here you see house martin, where the average total you get is along the bottom axis there. And the percentage of counts with house martins, the frequency of occurrence, the presence absence measure, is on the vertical axis. And you can see it's a pretty good straight line relationship. And that's because it's a species which is found in relatively small numbers and it isn't encountered very often. However, for a species which shows great variation in abundance, you're in trouble. If you look at the house sparrow there, there's quite big differences in numbers, around 2 to 2.5, from 1.5, with very little change in the percentage of the counts which have house sparrows in them. The method becomes really insensitive to real differences in numbers when you get up to, when you get a big spread of those numbers, and especially for the more numerous species. So the recommendation is to count, not to use presence absence. And methods that use presence absence have two problems. Not only have they less information about those more numerous species, but there's a curved relationship between the measure they're using, the percentage of the counts that have the species, and the actual density. So the measure they're giving you is actually misleading. So now, for greater precision, why don't we just look at those near birds and forget the distant ones? You could do that, and some people might want to because they have a very small location they're interested in. And it depends again on the questions you're asking. But if you do ignore those far birds, you're throwing away 60% of your detections. So normally you would look at the lot and make that distinction between near and far, so you can study the near ones separately if you wish, and you have that handle on the size of your study area. Now, how long should you spend counting? This curve that I show you here is based upon a huge number of studies, and you can see that the return per unit effort in terms of the number of species you find declines the longer you spend counting. You must get tired of it eventually. After about 20 minutes, you think, I'm not getting extra species at all fast. Isn't it about time I gave up? And if you make that duration a logarithmic curve, it's a straight line. This is well established in the literature, but it doesn't help us because the key point is not what happens at any one place, but what happens if you decide to cut your losses in one place and move to another place. Could be my garden tomorrow or next month or next year. It could be another counting point somewhere else in a different study. And what matters there is how different is this other place that you're choosing to move to compared with where you are now. And the more different it is, the more sense there is in cutting short your count and moving to count in a different place or different time. The more similar it is, the more point there is in sticking in one place. And if you're on an expedition basis, you're also tempted to spend longer. So there's no simple answer, and I need to study it. I haven't. It's tricky to study, and that's the next thing I'm going to be doing. So we haven't an answer to that question as to how long you should keep going before moving on and doing something else beyond that you want to be comfortable. So my conclusions. What do I conclude? Well, you can see them here. Point counts work well in small sites, but only if you can count a lot of point counts. So you need an easy routine, which is much more likely to be maintained than a stringent one. You need to choose points that are convenient as well as sensible for that reason. You need a convenient counting frequency and times, and season or seasons. Use binoculars, avoid extreme weather. Use a recording form. It's well worth doing because you've got spaces to put your results into. Otherwise you forget to make complete notes and you don't want to transcribe your information. Design a recording form and put it on a clipboard. Count all species because you don't know what's going to be of interest in 10 years' time. Count any birds that flee on your arrival, because a lot of them are not going to come back. They were there. In that snapshot, they were there. Count for 5 minutes. That's my best guess on the consensus. For each species, take a tally count of the total far and of the grand total separately. And I count overflying birds as far. And if in doubt that a detection is new, don't count it. That's it, folks.
Thank you very much, Dave. That was a really fascinating talk, really thoughtful, and I thought a lot of very helpful insights in people who are kind of considering taking on a bird counting in their gardens. And I like the way you were covering the why, all the kind of value that can come from these kind of studies, and also how to go about it. So there's a lot of actual practical guidance, your careful analysis of the data, and the the way that this kind of data can show really interesting trends, some that match the national kind of or bigger scale trends, and some that seem particularly localized as well. So thank you so much. That was really fascinating. what was quite interesting was that as questions were coming through in the chat, you then, a few minutes later, you then kind of, were kind of anticipating, and then you answered those questions. So in fact, I think most of what people have asked, you've probably actually really already covered very well in your talk. I think there was one question from Kieran. Do you want to ask that question in person, Kieran? To get us started, and if anybody else has got questions, please do add them in. We've still got time to take a few more. Kieran, do you want to ask a question?
Can you hear me?
Yep.
Yep.
I actually have two questions now. I'm going to ask a quick one first, Dave, just because you've taken us through your recommendations about how you can do a good census for bird recording. So that obviously tells us how we can gather our own data set. But I was just wondering, where's the best place to submit that data? Is there a central repository where the different ones can be compared?
No, and it's a great pity that there isn't. There is, of course, for your national schemes, but they don't translate down to the individual garden or individual small point. So you're not there really. What I would like to see, and this is a bugbear of mine, is record centres collecting as much information on the methods used as they collect on the results. Record centres are interested in keeping people happy, so they collect an enormous amount of information, which is quite anecdotal about what was where. But you have no idea how hard people looked to find that record. Such records which are unstandardized, you can make some sense of if you've got masses of them across a wide area, but it's absolutely useless in a small place. And I think that there's a great deficiency in recording schemes across the board in failing to collect what you might call the ancillary information that comes with records, bird track and so on. You can see tentative approaches to recording effort in some of these better run schemes, but it's still rudimentary and optional. And there's no published schemes where you can say, I use this method X, and so you can interpret my results. So for example, if somebody took my advice and they said they got a count of 6 great tits, you would know what they'd done. Whereas if somebody else said they saw 6 great tits in their garden, you would have no idea. And that second result is almost worthless.
Yeah, I think that's particularly pertinent with birds, which are so well recorded comparatively to other.
No, it applies across the board, not just birds. It applies to plants, it applies to insects. I've done a lot of work on it and a lot of different groups. And there's absolutely no doubt that across the board, the harder you look, the more you find. And you can quantify this, but nobody records how hard they look. Not even in a rudimentary fashion, or very few people do. So it's not just birds.
Okay, the second question I had, it's a little bit more of a throwaway question, but I was just wondering, with your looking at lockdown impacts, would we necessarily see the impact of lockdown in the first year, or could that be something that maybe shows up this year or next year?
Well, I'm afraid we are leaving lockdown, so that question may be serious. But let's assume we keep going on lockdown. Yes, it's a bit like my my cataract operation. You might find a step change, but really, when you're doing a scientific study and you're looking for the effect of something like this, you need a long period of control observations in places locked down and not locked down. And then you look at what happens in places where lockdown is applied in one place and not in another. And then hopefully lockdown comes to an end and you see the lockdown place recovering back to the non-lockdown place. Forget it. You're not going to be able to get that kind of detailed, high quality result out of the sort of thing that we're doing here or people are doing in the national schemes. I'm prejudiced as a bird population ecologist anyhow to think that lockdown will have practically no effect on birds. But that's just my prejudice. But I'm quite convinced that we will have great difficulty finding good quality information to address the question. My information isn't sufficiently high quality, and I can't think of anybody else's. And lockdown's going to come to an end. Much like my garden.
So thanks ever so much. I think we've just got a couple of questions in the chat. If we can, we've got, you know, only a minute or so. David, is there a couple of things just to pick up?
Yeah, I'll combine a couple. There was a question from Gino and a question from Jeff. So Gino was asking about, do you know about what your neighbours are doing? There's been any change in what they're doing in terms of bird feeding and so on during this?
Yeah.
And Jeff was also asking, you mentioned bird feeders, so I'll combine the two.
Yeah,
do you think there's any reason for differences between your trends and the national trends for things?
I'm sad you've asked that question, because bird feeding is something that I haven't got a good handle on. I have in recent years been documenting my own feeding of birds, but it's quite difficult to tell what my neighbours are doing. But a lot of them are doing what you might call sporadic bird feeding. Most of the time their feeders are empty. And I do intend to try and have a look at it in my own data, but it's only in fairly recent years where I've recorded it well enough. And for example, the last 10 days, I've left my feeders empty, and I'm going to fill them up soon. I'll do 10 days with them full. This is the kind of thing you've got to do. And I'm pretty well convinced that the species that come regularly to my feeders are influenced in their presence in my garden by the fact that I'm feeding them. But I haven't collected the data and analysed it in a way in which I can prove that. And it's partly because I wasn't systematic enough about recording my own behaviour until fairly recent years. So that's an unanswered question, but I'm aware of it.
And then the last question is a good one to end on. Tony Edwards asked, how can people who are perhaps not as experienced as you as ornithologists contribute to counting and collecting this sort of data?
Well, of course, you can join those national schemes, and that's the first thing you ought to do, because the best national schemes are actually very good. They produce good data. Their problem, as I've indicated earlier, is that they don't translate down at all well to a small site. So that's a deficiency in the national schemes, but they have great advantages. So don't invent your own thing. The first thing to do is to join a national scheme. And the other thing I would say is that don't be modest. The best way of learning your birds is to set out and start counting them. And if you have to put a name on every fleeting glimpse and every noise, unless you're really long in the tooth and have pretty poor faculties, you're going to pick it up pretty quick. In New Zealand, we had 4 counters in one study, one of whom hadn't studied birds at all before. He counted alongside 3 others. He got comparable results, not quite so good, but he was rotated around all of the counting areas. So his results went into the mix alongside of everybody else's, and they were far from worthless. He picked up the field signs of birds quite quickly. And if you want to start documenting things and, learning field signs of species, by far the best way is to go out there and try and count them. Because to begin with, you'll discard those first few months or maybe even a couple of years of effort, because a lot of them were those odd noises that you haven't pinned down yet. But once you've pinned them down, you've really got them, because you now know what that strange noise is. You've got it hardwired. And from then on, you know what it is. And it doesn't take long. So don't be modest. It's easy. It just takes a bit of application, but it's not everybody's thing. So if you want to do it and not collect stamps or something, give it a go.
That's a really inspiring end to the session, actually. So hopefully, you know, everybody who's kind of thinking about this, you know, decide about giving it a go, and that, you know, you can start from not having very much knowledge at all and build it up. That's really positive ending. So thanks ever so much for that, Dave. That was a really fantastic talk. There's a lot of lovely positive comments coming through from the chat as well. People saying how clear it was and how thorough. So thank you very much, and thank you to everybody who took part as well. That's really been great to kind of see all of you and to see some new faces as well. Thanks again to the Ecology and Conservation Studies Society for working with us and for planning this talk. Our next LNHS talk will be on Thursday, the 22nd of July. Celine Gamble will be talking about oyster restoration in the UK, about restoring a forgotten ecosystem. And you'll find out about the important role that oysters can play, their status, their decline, and about restoration efforts. So do sign up for this talk. It's proving popular, but we do have some spaces. Please see our website for details of all our forthcoming talks and to sign up to the Virtual Talks mailing list. And we hope to see you all again very soon. You can unmute yourselves or put your videos on if you'd like to say good.